Hi students, so in this video I'm going to solve a problem in which a dam holding back water in a reservoir consists of a vertical retaining wall 10 meters high, 10 meters wide and 6 meters high. The water has a density of 1000 kg per meter cube and the water level is 1 meter from the top of the wall. Now, it is essential because when designing and building dams, it is essential that engineers understand the forces that will be acting on the dam so it can be made to withstand them. So, in order to solve this problem, I'm going to draw a small diagram for the dam. So, that's my dam holding water. There is no water on this side. There is water on this side of the dam, and water has a density and the level is 1 meter from the top. So if this is a 1 meter, that's the water level. So this height will be 5 meters, and this side of the dam there's nothing. The water is on this side of the dam. This dam is holding the water. Now, before you solve a problem, it's a good practice to write down all of the given data. Height of the water is 5 meters. Height of water, that's H for height, prefix W for water, is 5 meters. That's 5 meters. Density of the water, which is given by rho, is 1000 kg per meter cube, and the water level, this I have noted down, it's 5 meters. What else do we have? The wall here, the width of this wall, so imagine that's your dam. The width of the dam is equal to 10 meters wide, so that's 10 meters wide, and that's all the information that we have. Now let us start calculating the A part. Calculate the resultant force exerted by the water on the dam. So that's my thrust force acting on this dam because of all this water. So I'm going to denote it as F, or force, or thrust force, and that is equal to, if you take a look at your formula sheet, at the very end, the very last page, under fluid principles, you have hydrostatic thrust on an immersed plane surface is given by rho, G, A and X. So I'm going to make a note of that formula, rho, G, A and X. Now, rho is the density, G is the acceleration due to gravity. So my G value is 9.81 meters per second squared. X is the average height of this dam. Now this has a height of 5 meters. So if I consider the average, that is the average height. If I consider the average of 5 meters, it is 5 divided by 2. So all of this thrust will be acting at a point, say somewhere in the center of this, which is about 2.5 meters from the top, 2.5 meters from the bottom, somewhere over here. So my X is equal to height of water divided by 2. So again, I'm going to rewrite this formula as density times gravity times, this area is the cross-sectional area of the dam. So imagine this is my dam. I want to know, and the water level is up till here. So I want to know this cross-sectional area. That is going to be equal to the height times the width of the dam. So area is equal to the height of water times the width of the dam. rho g area times my x is equal to height of the water over 2. Now what I'm going to do is I'm going to substitute all the values that I have here. So my thrust force is equal to, I'm solving the A part now. So let me make a note. Thrust force is equals to 1000 times gravity 9.81 times height of the water, which is 5 meters, times width of the dam. So that's the width of the dam, which is 10 meters, times again height of the dam is 5 meters over 2. So I have my expression here, and I'm going to use my calculator to solve this. So that's my divided by, on the top I have 1000 times 9.81 times 5 times 10 times 5 again, and in the denominator I have a single 2. That's going to be equal to 1226250, or 1,226,250. 1,226,250 Newton. So that's my total thrust acting on this wall because of all of this water, which is 5 meters high. Now this is written in Newton. Now this can also be written in terms of kilonewton or meganewton. So this will be equal to 1. So what I'm going to do, I'm going to write the whole number again. 1226250. Now if I want to write this in kilonewton, basically I have to move the decimal place 3 places to the left. So my decimal place is here, and I move it 3 places to the left. Kilonewton. And if I want to write this as meganewton, then I move the decimal place more 3 places to the left. So I'm going to write the number again. 1226250. So 1 2 3 4 5 6 places, meganewton. Now this is just something for you to know what is kilonewton and meganewton. Kilo is basically 10 to the power 3, and mega is 10 to the power 6. And all you're doing is just moving the zeros to the left to just get a higher unit. But it is better if you leave your answer in terms of Newton in your exam. So that's my total force, total resultant force exerted by the water on the dam, and it is going to act somewhere here. Now we calculate the B part. Calculate the overturning moment acting around the base of the dam that the structure must be able to withstand. So I'm going to keep this aside. B part is overturning moment and I'm going to name it MT. Now when you have a dam which is built and all of this force is acting on the dam, there is going to be an overturning moment. What is an overturning moment? All of that force will want to topple this wall over in this direction. So this wall here will want to fall on this side, and that moment will be felt at this point there. So this wall will want to topple. We have to calculate this overturning moment so that we know how much overturning moment this base point has to withstand, so that we can build a stronger foundation. This overturning moment is equal to the thrust, F thrust, that is the total thrust acting on the wall, times the distance at which all of this pressure is acting on the wall. Now in order to understand this concept, we got to understand a concept of center of pressure. So now imagine you got a triangle here, and I'm going to draw the pressure profile. So what I mean by pressure profile is, at this point here, it is at a height of say of 0. From it is the height of the at this point the height is 0 at which the all of the pressure is acting, and hence because the force exerted is equal to rho g a x, and at this point, since my x equals to 0, my force exerted will be 0. And as we go down, the pressure increases. This is seen in case of professional divers. When they go deeper in the water, they feel a lot of pressure exerted on their ears. So that explains this pressure, because as the diver goes down, the pressure exerted on the ears is a lot higher, and that's true because of all of the water over the head. At this point here, the pressure will be rho GA and 5 meters. So at this point it is going to be maximum. So at this point, that's my pressure profile. The pressure felt at this point will be maximum, which is about here, and I'm going to complete my triangle. So at this point the pressure is lower, a slightly higher here, slightly higher over here, more than this. As you go down, at this point it is maximum pressure. So this is my pressure profile acting on this dam. And when we solve problems, we got to assume that all of this pressure is acting at one single point. Now that will be acting on the centroid of this triangle. We got a triangle here, and the centroid lies roughly 2/3 from the top or 1/3 from the bottom, this point here. So moment is equal to force times this distance, that is the point at which the center of pressure lies, and that distance is 1/3 of the height of the dam, times 1/3 of the height of the water. Not the dam, it's the height of the water. So my F thrust is equal to 1,226,250 Newton. 1,226,250 times height of the water is 5 meters over 3. So I get my calculator out again, use my divided by 1,226,250 times 5, and it is divided by 3. That is going to be equal to 2043750. Keep it aside. 2043750. The units for the turning moment MT will be Newton meter. So that's my turning moment MT. Now that's the problem solved. You were asked to calculate the resultant force, which is calculated here, Ft. It's a good practice to highlight your answer so that the examiner will have can find your answer with ease. So when you have a dam here with water 5 meters high with width 10 meters, it will have a turning moment felt at this point, which will be equal to 2043750 Newton meters. And if I was to write it as kilonewton or meganewton, which is usually used when you solve problems, I can write it as 2043750 1, 2, 3 places, kilo Newton meters, or it is equal to 2043750, and you got 1, 2, 3, 4, 5, 6 mega Newton meter. Now this is only for your knowledge sake. To understand what are kilonewtons and what are mega newtons, you simply multiply this answer with 10 to the power minus 3 or 10 to the power minus 6 to get your answer. You don't really need to do this. This is just for your knowledge sake. What is kilonewton and mega newton? These are my solutions. Now what I want you to do is stop this video, make a note of this problem, and try to solve this problem again without watching it. Good luck.